Welcome to the Chapter 3 project tutorial. The name of this project is Sneakers and Jeans, so I bet you can guess what we're going to be working with for observations for this project. My class thought it would be fun to observe the number of students wearing jeans and the number of students wearing sneakers in the class. So we can construct this two-way table and fill in frequencies for students wearing jeans or sneakers or different combinations of jeans and sneakers. And then we'll convert those frequencies into probabilities to answer questions about specific events in this project. So to start with, my students looked around in the classroom and counted how many students in the classroom were wearing jeans, and they came up with a total of 8. The next thing they counted was how many students were wearing sneakers, and that total was 7. So right away you can tell that not all the students that were wearing jeans were also wearing sneakers. The next count was how many of those students were wearing sneakers and jeans at the same time. That count was 4. The other count the students made was observing how many students were not wearing sneakers and not wearing jeans at the same time. And there was only one person not wearing jeans or sneakers. Now with that information filled in, we should be able to fill in all the rest of the empty boxes in our two-way table. Because we know the total of students wearing jeans is 8, and 4 of those is already accounted for, 4 plus something must make 8. So that would be another 4. 4 plus 4 makes a total of 8. We can do the same thing now with the students wearing sneakers. We know that there are 7 total. 4 of them have already been accounted for. 4 plus something has to make 7. So the missing number is 3. All right, now we just need to figure out what the total number of students not wearing jeans is. So that will come from 3 plus 1, which makes 4. Going horizontally, we need a total for students not wearing sneakers. That would be 4 plus 1, or 5. The grand total now should be a match no matter if we go vertically, 7 plus 5, or horizontally, 8 plus 4. No matter which direction we go, the total is 12 students. And sure enough, there were 12 students in the classroom on that particular day. So what we will need to do now in part 2 is to determine the probability of some given events. Event J is the event that students in the classroom or your own sample are wearing jeans. So I go to the wearing jeans column. I need that total. I have 8 students, but remember we're going to find probability, so we're not going to write 8 there. So what we're going to do to find that probability of students wearing jeans is first I'm going to write it this way. Probability of event J would be 8 out of 12. Now with your calculator you can take 8, divide that by 12, and you will find that it is 0.6 repeating, or we could take that out and round it to 2 decimal places for 0.67. That'll be a little easier to work with, so feel free to round off to the nearest hundredth for your own project if you need to do any rounding. Now you'll go ahead and fill in the probabilities for these other events as well. So right next to your frequency, if you want to do this in your table, I could have done 4 out of 12 equals 0.33. 4 again out of 12 is the probability, 0.33. And I can do that for each one of these frequencies. 3 out of 12 is 1/4 or 0.25 probability. And I would need to do the same with 1 divided by 12. That's 0.08. Of course, 12 out of 12 will equal 1. Remember, the total of probabilities must equal 1, nothing less, nothing more. Once you change or convert each of these frequencies into probability, that will help you with part 3, because you'll be making a probability Venn diagram. So I'll start by creating my sample space. That's what S represents, sample space. Inside of your sample space, you're going to represent your events. We have 2 events. J is the event of wearing jeans. S is the event wearing sneakers. Now I can see that there are 4 people in our observations from the classroom, that 4 people were wearing jeans and sneakers at the same time. So I need to be sure to draw my events so that they are overlapping. One event is J, the other event is S. That's what we're given in the directions. Notice that the intersection is our 4 students out of 12, so that's 0.33. I can go ahead and fill that in. So far, the total that I have for my Venn diagram is 0.33 because I have no other probabilities written to add to that yet. So I know for sure this is not complete yet. The next thing that I would do is I need to fill in this balance for the students wearing jeans. Notice that the total number of students wearing jeans is 8. We found out already that 8 divided by 12 gave us 0.67. So don't write 0.67 here. That shows a total of 0.67 added to 0.33. So that is the typical mistake that people make on the project. So you don't want to do that. Okay, let's get the eraser and get rid of that. So to figure out what balance is left over, go back to what the total is supposed to be for the event wearing jeans. We calculated that as 0.67. So off to the side here, 0.67. Let's take away 0.33 because that's the probability that's already been accounted for in event J. So if I take 0.33 away, I'll know how much is left over to write over here. I'll get the decimal ready to go. 7 minus 3 is 4. 6 minus 3 is 3. So I have 0.34 in this portion of event J. So notice when I add 0.34 to 0.33, don't I have 0.67 total? And that's exactly what we expect it to match with. All right, so I will be filling in some probability to balance out what total should be in event S for wearing sneakers. I already have 0.33 accounted for, but I'll be adding that to something else that should match the total for event S. I might also need to have another probability outside of the events, because look at here. I have one student that was not wearing jeans, not wearing sneakers. So that one student out of 12 would need to be accounted for right here. So that's where that 0.08 would be written. So far I have 0.34 added to 0.33 added to 0.08, and that is not making a sum of 1. So That's what's going to help me fill in this missing probability here, because you know that the total must equal 1. So I hope you're going to be able to do this with the numbers you come up with from your observations. Moving on to part 4. Here, you're going to be using that set logic notation attachment that I provided for you in Blackboard. It's also provided in my Stat Lab, but you'll be using that to help you know the difference between the symbols needed, union, intersection, and complements, because you will be writing these events using set logic notation. The students are wearing jeans and sneakers. The word "and" tells us we're looking for intersection. We also are using J for the event jeans, S for the event sneakers. So if it's jeans and sneakers, that means jeans intersect sneakers. That's all I'm doing here, is writing that set logic notation. Notice here in red it says do not calculate probabilities. So you don't need to do anything more except write the set logic notation. And finally, for question 5, it says, are the events students in the class are wearing jeans and students in the class are wearing sneakers mutually exclusive? So it's kind of a vocabulary check here. Are those two events mutually exclusive? If you answer yes, make sure you explain your answer or reasoning. If your answering is no, then make sure you're also explaining why you're choosing no for your answer. I hope you found this tutorial video helpful with your Project 3.